Hi, I am Yunus Emre Avcı. My project is volumes of polytopes. In this project, we combine two notions of polytope volumes, namely the Euclidean volume and the discrete volume. The Euclidean volume is a classical notion of volume, while the discrete volume is the number of integral points in the polytope. For example, in a cube of side 2, Euclidean volume is 8, discrete volume is 27 as shown in the figures. For realizing project, shown requirements should be done. Those are experiments for Ehrhart polynomial computation, approximate Euclidean volume using fast algorithms, combine fast volume algorithm with Ehrhart theory, and then finally compute discrete volume. Tools of the project are Seagull, Emre code volume approximate, Polymac, Latte, and Python. The installation of the programs is not always easy, so we decided to use Docker file for necessary tools. Let's see the Docker file. Necessary libs for our tools here, and the steps of the installation of tools. Flowchart of the project like as shown here. We are getting the polytope from inequalities file, and we are applying the T dilation to polytopes, and we create new in a file. We are using the Emre volume approximation code to get Euclidean volume. With this Euclidean volume result, we can get new bounds, and we are applying binomial monomial basis to get a LP file. We are using GLPK here for linear programming to get H vectors to Ehrhart polynomial. Over Ehrhart polynomial, we can reach the discrete volume of. Let's look at Ehrhart theory. It is the main step of the project. Ehrhart theory steps and found lattice points of equivalent t-dilate values are shown on each click. For t, if 2 is equal 1, then the lattice point number is 4. If it's 2, number 9. 3 is 16, and finally the general function, we can get general function which with Ehrhart theorem. Definition of the Ehrhart theorem is given a lattice polytope P is subset of R to the counting function LPT is equal to number of dilate P is intersection of Z to the is polynomial of degree D in the variable T. Success criteria of the project: report on Ehrhart theorem and approximate volume computation, implement a method for integer polynomial approximate interpolation, and finally implement a method for computing the Ehrhart polynomial using the volume of polytope. Let's demo to see result and steps of the. Let's demo to see the result of the project. Before that, there are two execution type on project. First one is get exactly 1 point, and on another one we can see all candidate lattice points on search area. First, I'll try for all candidate lattice points. Firstly, we should run the volume approximation code with make, then we should run script code to reach the result. I'm giving the cross polytope with 2 dimension and 3 dilation values. We can see bounds and inequalities of the polytopes, and we are doing 10 experiments in this project. We are getting the bounds from those experiments result. Those are the candidate lattice point polynomial, and those are the candidates for Ehrhart. Finally, we can two types polynomial. First one is polynomial of latte, and another one is polynomial of volumes. We are comparing these two ones to see result, and they are not equal, so the result is false. For the another type, exactly 1 point, we are doing the same running steps, make for volume approximation and Python script code running. I'm giving the view code Polytope with 3 dimension and t values is 8. The output of the same with previous one, except there is a one h vector h values, and there is one Erhard polynomial. Steps are same. Finally, there are two types of polynomial, where again we are comparing these two, and we can see the result here. They are not same, so the result is false. Thanks for listening to me.